Hello, Dr. Ron England here, and we're going to talk Python and parallel arrays. And I know that was a problem that we had in the class, and just kind of showing some complexity of how to solve problems with Python. And I know you're learning the language Python at the same time you're learning how to solve problems, so I understand this has got some complexities to it. So I'm going to actually give you the solution to this one. And yes, you can use it. But I wanted you to fight with it to understand the complexities first. I mean, it doesn't mean anything to you if you don't actually do that. So here I'm going to give you an example, and this is a typical example of actually reading some values off of some gauge or some chart at different times. So I've got two arrays, time 0, 1.2, 2.5, and 3.7. And what I did is I read values off of something at those times. So the values here are 0, 7.5, 11.4, and 14.7. As you notice, the time and the values correspond with each other. So what we want to be able to do is we want to be able to estimate what the value would be at some time that was not one of the times that you read. And that's where you get into the concept of parallel arrays, because what you have is two arrays of numbers, and they are parallel. They actually follow each other. So let's first look at the concept. Now, hopefully by now you understand the concept of an array. This is array means that I could say, and let's go ahead and let's just simply do some of this. Okay, so if I take these two arrays and I put them into memory, and I say, well, you know, what is time? Well, actually, let's print it, because we can print it down. Print time of 0. Okay, and let's do that. Now, if you come down here, time of 0 is 0, and that's what you would expect. And time of 1 should be 1.2. Same thing with vowels. If I do print vowels of 1, I should get 7.5, which if you notice down in the console, that is exactly what you get. So that's simply accessing the values in the array. Now, one of the most useful ways of solving this problem is saying, well, if I get any time in that range, 0 to 3.7, okay, can you give me back the value that would be associated with it from the vowels array by using interpolation? And in this case, the interpolation that we're going to be doing is going to be in two steps. The first step is to take the time, pass it to it, and from the time, get back the actual index. Now, the trick here is that the index is not going to be an integer index, even though an array is referenced by integer indexes, because the value is going to be between two indexes. So let's look at how we would do that. So the first step of get index, and I'm writing a function get index where I'm passing in a value and the array. So v and a correspond with a value and an array. And if v is less than the array at 0, well, guess what? If it's less than that, then I'm just going to return a 0 because it's below that. I can return undefined, but I'm returning a 0 because it's nonsense. Also, if the value is greater than the last element in the array, and here I'm introducing a function, len of a. Length of a will give you the number of elements in an array. Now, watch closely. The elements in the array, 1, 2, 3, 4. But this fourth element is referenced as element 3 because it starts at 0. 0, 1, 2, 3. And it doesn't start at 0 because I started with a 0 here. Arrays always start at element 0. So, this fourth element is referenced as 3. So the length of the array being 4, well, 4 minus 1 is 3. So if v is greater than the element at 3, then return that index directly. Okay, so if you do that, then those are two of the cases that I just handled. Now, the reality is you probably didn't have to worry too much about those situations, but in this case, I like to handle all situations in my code. Now, everything that's in the middle is what you're going to have to be able to handle. So let's look at everything that's in the middle. And what I'm going to do is I'm going to run a for loop. And I'm going to start at 0, and I'm going to go to the length of the array A. And actually, I should never get to the length of array A because I handled that situation right here in this code. Now, I did throw a print here so that you could see what's happening when I run this. But this is really straightforward. If the value of the array is greater than v, so in other words, let's say I put in an 8, or let's go up to the time. If I put in a 2, well, at 0, okay, a of I is not going to be greater than the value if the value is 2, 1.2. Well, A of I is not going to be greater than the value if the value is 2. But then I get up here to 2.5, and yes, A of I is greater than 2. Well, what that tells me is that it's between 1.2 and 2.5. The element is between those two. So if A of I is greater than V, then I'm going to actually return I minus 1, which is going to be the index of the element before you got greater, plus the fraction, which is V minus A of I minus 1 over A of I minus A of I minus 1, the fractional interpolation between the two. That's the function. So let's go down here and let's actually do this. I'm going to set the value here of N1 and N2. I'm going to do two of them. N1 and N2 are going to be get index at 2 and get index at 0.5. So if I hit those two, and let's go up here and look at N1. N1 is 1.615. I don't need to go any further, but it corresponds with a past value of 2. So if I go over here, 0, 1, okay, well, look at this. It's between 1.2 and 2.5. Okay, 2 is somewhere in the middle of there. So it should be somewhere between element 1 and element 2, and the fraction between element 1 and 1.2 is 6.5. So it's in the between element 1 and element 2. All right, well, let's look at the 0.5 one. End of get index of 0.5, passing over the array time. Okay, well, 0.5, well, that's going to be hopefully between the first element, which is element 0, and element 1, because 0.5 is between those two. And if you look over here, it's actually 0.416. So with end 1 and end 2, those are actually showing me how to get that index. Now, I'm going to throw some spaces in here because sometimes this is hard to read. So if I move it up a little bit. Now that I know the index in the first array, I should be able to, and I can actually bring this down a touch, I should be able to then get the value associated with that index. So here's how I do this. Now, this one's not really terribly challenging. I'm going to write a function called getValue. I'm going to pass the index, and the index has to be an actual index like you would have an array, but it's not an integer. So I do is I set the lower value. This would be the actual index of the element that's below the one at index, just to be the int of index. What that's going to do is it's just going to strip off the fraction. So if it's 1.615, lower is going to be equal to 1. If it's 0.416, lower is going to be equal to 0. And that's going to allow me to get the value at the lower one. So I get the lower int, then I say, well, the fraction, in other words, the other part of that, I now know where the 1 is in the 1.615. I now need the 0.615. Well, the fraction is just the index minus lower, because lower is what you get when you strip off the fraction. And now the interpolation is relatively straightforward. I'm going to return A of lower plus whatever it is above that, which is going to be the fraction, times lower plus 1 minus lower. Now, can I do this? Let's see. Let's actually pass the end 1 and the end 2 over and see what I get for answers. So in the case of end 1, the fraction was 1.615. Well, the 1.615 would put it somewhere in here, and the value was 2. So it should be somewhere between 7.5 and 11.4. My answer is 9.9 that I got back. And if I look at the one with N2 in the values, well, 0.416, 0.416, put it between 0 and 1.2. Then when I went ahead and did the interpolation in the second half, I get 3.125, which is between 0 and 7.5. So this is two-step interpolation with parallel arrays. Yes, it is complex. It's not impossibly complex, but what it does demonstrate is how challenging you can get with just applying simple logic as you go through it. Now, the best way to solve some of these is to first attack them by hand. How would you do it? And then start thinking about how you can attack it as a computer program. So hopefully this has been incredibly useful to you, and good programming. The problems are going to be about at the same level of difficulty, but the goal here is to get through and be able to solve these types of problems and learn these techniques. Thank you very much. Good programming.